Actually, this one, winter 20, question paper 1-3. And starting with the first question. Oh, which of these statements is correct?
First one is wrong.
Okay,
Is it C?
I see it as a relative molecular mass of 162.4. Yeah, I think that's right. What do you think? Anyways, and this one, just a second, let me just check. What's wrong with D?
D is supposed to be ionic.
So if they had written the same thing for D correctly, what would have it been?
Relative ionic mass.
No, formula mass.
Formula, yeah.
So for ionic, they don't use molecular, they use formula mass. The first one is wrong. That's isotopic mass is for isotopes, while this is the average of all the isotopes. Anyways, you got this equation. What is the maximum mass of strontium metal? This one, which can be produced from the reduction of 100 grams of strontium oxide using this reaction. So this is 100 grams. So quickly, how many moles is that? Like, what's the MR of SR? That's
MR is 103.6.
the entire MR or just
Strontium and oxygen.
103.6? So what are the moles?
It's 0.965.
0.965. So those are the moles of strontium oxide. So you're supposed to figure out the mass of strontium. So that's half of that, right? So what's half of that?
0.483.
So that's 0.483 moles. And you can find the mass now. I'm multiplying it by the ER, sorry.
I got it as 42.3.
42.6?
0.3.
See, that's 42.3. Next one, a single P nucleus can be, or phosphorus nucleus can be produced when a single S nucleus joins with particle X. In the process, a proton is emitted. What is particle X? So P32, I mean, the proton number is fixed. That's 15 in the periodic table. So he says this is produced when S32, which has a proton number 16, joins with particle X. And in the process, a single proton is emitted. So P is produced and a single small proton is produced. What is X?
Is it a neutron?
No, maybe it is. So how many protons does it have? It's got 16 protons, 16 neutrons, and 16 electrons, right? What do you have over here? You got 15 protons. How many neutrons? 17?
Yeah,
And
17.
you got another proton over here, right? So the protons add up to be 16. Yeah, you need an extra neutron, right? So that's the only thing that's missing. So it's C. As the next one, in which of the following, when in liquid form, are there only intermolecular forces based on temporary dipoles between the particles? So which one only has temporary dipoles?
Hydrogen chloride.
Which one?
C.
No, it's A.
No, temporary dipoles. So bromine.
Yeah. Yeah, that's when that's instantaneous dipole induced dipoles. That's van der Waals force. So that's A. Copper has a high melting point. What is the reason for the high melting point?
Strong attractive forces between ions and denuclearized electrons.
So it's metallic bonding. It's basically a bunch of ions attracted to delocalized electrons. Which pair of standard enthalpy change are numerically equal?
Is it the last one?
The last one?
Because neutralization produces 1 mole of water.
No, the last one is not the same thing because neutralization is when an acid and a base they react and they produce 1 mole of water, right? I mean, that's what neutralization is, right? While formation of water is when elements H2 and O2 they react and they form 1 mole of water. I mean, formation is when 1 mole of something is produced from its elements, right? So it's not the same reaction. So D represents two different enthalpy changes. Is that clear?
Yes. Is it C then?
It is C. Combustion of graphite is carbon. It burns, combustion, and it produces carbon dioxide. And formation of carbon dioxide is the same thing. That carbon dioxide gets formed from its elements. So they both represent the same reaction. So it's exactly the same enthalpy change. That's the next one. You've got this energy cycle. The standard enthalpy of formation of BRF3 liquid is given. The enthalpy change of you're given enthalpy change of BRF3. What is the average bond energy of BRF bond in BRF3? Like there's a bunch of things missing over here. Do you think what is the energy value for this?
It's 2 times minus 301.
2 times minus 301. Enthalpy of formation, BRF3 getting formed from its elements, right? So that's right. But twice. What is this?
This is 44 times 2.
Liquid to gas, right? Okay, and what's this equal to?
Is it 1212?
Nee, that's the answer. You calculated the answer.
Yeah.
So, I mean, but this was basically the BF bond energy multiplied by what? Multiplied by 6, right?
Yeah. So we have to divide the value by 6.
Okay, just do it one time. I'll check the answer. So you basically, I mean, there are two parts, right? So this is your one part, and that's your other part. So it's 2 times minus 301, and that's equal to what? Plus 698. And then you have to go the other direction. So it's minus 6x. I'm going to just call it x. And then it's minus 44 times 2, right? So what is 6x equal? I'm going to take 6x over here. So it's plus 698 and plus 301 times 2 and minus 44 times 2. And the whole thing gets divided by 6. So are you sure you got the right answer? Let me.
Is it B?
Let's check. So B 202, right? Which question was this? 7, right? Yeah, it's B. Okay. Just make sure double check your calculations when you have a lot of additions and subtractions. In which reaction does the greatest change of oxidation number of sulfur occur? Which one is it?
Is it the first one?
Yeah, it's the first one. So 0 to plus 4. Now the first stage in the chloride, well, I think it's the first one because the other ones they don't. What is the oxidation state of sulfur over here in H2S2O7?
Plus 6.
Plus 6. So I mean, this is not a redox, right? Because it's plus 6 and it's plus 6 over here as well. Let's anyways, next one. Well, the first stage, there's this thing. What is reduced in this reaction? Who got reduced?
Chlorine.
Yeah, chlorine got
Is it?
reduced.
Yeah.
There's 0 and it's minus 1 over here, right? Carbon got oxidized, 0 and plus 4, plus 2, sorry, and plus 4 as well. Now, there's this thing going on. There's acid that is dissociating. Uh, now remember one thing about about about. Do you know what a diprotic acid is?
It can donate 2 hydrogen ions.
Yeah. So whenever you have a diprotic or a triprotic acid, even if it's a strong acid, right, like phosphoric acid. So. I said now diprotic or triprotic acid, like phosphoric acid. The first dissociation, I mean all the 3 H+O ions, they don't dissociate immediately. What happens is that the first dissociates, and that dissociation is very easy. Then this ion gets formed, and this one dissociates another H+1. And it becomes, so there's one more H+1 gone. Then this one dissociates another H+1. So the last one, H+1 is also gone, right? So finally, you've lost all 3 H+O ions, but they don't happen simultaneously. What happens is it's one by one. Now the first dissociation is always very strong. While the last dissociation is very weak. Can you answer me why the last dissociation is very weak? Like it's very easy for phosphoric acid to lose one H+1 ion. But it's very difficult for phosphoric acid to lose all 3 H+1 ions. Like especially the third one.
Because there's the strongest attraction between the ion and
Yeah, because the
H
negative charge increases, right?
Yeah.
So there's stronger and stronger attraction for H plus one ion, right? So which is why over here in sulfuric acid, the first one was complete, right? It was strong dissociation, but the second one did not happen fully. It just ended up reaching an equilibrium. So he says analysis of a 2 mole per dm cube solution of sulfuric acid found that the HSO4 ion concentration to be 1.98 mole per dm cube. So you know that in your solution, the H plus one constant, I mean, so the HSO4 ion concentration is 1.988, right? Can you tell me what Kc is? And can you tell me what is the concentration of sulfate and H plus one? And you have to find Kc for this. And you started with 2 mole per dm cube, right? So the first dissociation was complete. Jody, any idea? Yeah, any idea?
I mean, not really. I'm confused. Which values are we going to take?
Oh, you see, let's talk about the first dissociation. The first dissociation is complete, right? You started off with 2 mole per dm cube sulfuric acid, all of it dissociated. So the HSO4 ions and the H plus one, what's the concentration? That's 2 mole per dm cube, right? Because all the sulfuric acid dissociated. Is that clear?
Yes.
Now, what happens after that? After that, your HSO4 is going to dissociate. You know the initial concentration of it. So the initial concentration was what? After the first reaction, that was 2 mole per dm cube, right? But then he says that the concentration is not 2 mole per dm cube, it's actually 1.988. So that means this sulfuric acid, this sulfate, hydrogen sulfate ion, some of it dissociated as well. So that 2 mole per dm cube, which was produced in the first reaction, a tiny bit dissociated. What is that tiny bit? That's, can you subtract 2 and 1.988?
0.012.
So that means 0.012 dissociated as well, right? So it's going to produce how much sulfate ion? That's going to produce 0.012. And this will also be 0.012. So is that clear that your initial starting point was that you were supposed to have 2 mole per dm cube? But you didn't have 2 mole per dm cube, you had 1.98. So that means out of 2, 0.012 dissociated further. And they ended up producing 0.012 and 0.012. And you were left with 1.988. Okay? Is that clear? So you now have the equilibrium concentration.
Yes.
And your Kc value is now going to be product concentration is 0.012 into 0.012. And divided by 1.988. Is that clear?
Yes. Is it D?
So yeah, that's T. So you've got an autocatalytic reaction. Is a reaction in which one of the product catalyzes the reaction. Which curve would be obtained if the rate of an autocatalytic reaction is plotted against time?
It's C.
Okay, so it's going to be slow in the beginning. Products get produced and the reaction speeds up and then it slows down back again. A section Y are two elements in period 3 of the periodic table that combine to form compound Z. X forms a soluble acidic oxide. Can you list soluble acidic oxides in period 3?
SiCl4 and
The
PCl3.
oxides.
Oh, oxides.
SiO2 is not soluble. P4O10 is soluble, right? It forms phosphoric acid. And sulfur oxides are also soluble. I mean, phosphorus has two oxides, P4O6 as well, right? And the rest are insoluble: aluminum oxide, magnesium oxide, silicon oxide, sodium oxide, but that's basic, right? The oxidation number is +4, so I think that's I guess that's sulfur dioxide, right? Is that clear?
Yes.
Which of the oxides is amphoteric?
Aluminum.
So you got Al2O3, that's amphoteric. So basically, what is a compound of? So what happens when X and Y combine? That's aluminium and sulfur. What's the formula? I mean, that's only one given. That's. Okay, is this clear?
Yes.
The next one is the questions about two elements in group 2, Q and R. Three of the statements shown are correct for metal Q. The one remaining statement is correct for metal R. And it's group 2, right? They didn't really mention anything. So which statement applies to R? So three statements are true for Q, but one for R. I mean, that's
Is it B?
which one?
B.
Well, if R reacts quickly with cold water, right? So is it at the bottom or is it at the top of group 2?
It's at the bottom.
So Q must be at the top and R must be. So that means the rest of the three statements must be true for Q then, right? So the metal has the greater atomic radius. Wrong. Do you understand the question?
Yes, I got it.
Okay, so this one is not. So you have to basically do trial and error. Let's look at let's say the first one. The first one is true for R, right? A saturated solution of the hydroxyl, is it at the bottom or at the top?
It's at the bottom because pH increases down the group.
So R is at the bottom. So that means Q is at the top, right? So the metal has a carbonate that is used in agriculture to produce the acidity of soil, right? That's kind of possible, right? Calcium is at the top, right?
Yeah.
The metal has the greater atomic radius. That's wrong, right?
Atomic radius increases down the group.
Yeah, so Q will not have the greater atomic radius, right?
Yeah.
So that means it can't be it can't be A, right? Let's say that C is correct for metal R, right? So again, that makes C at the bottom, right?
Yeah.
So that will not work because the other statement will not be true for Q. More quickly with cold water, that's not going to be Q, that's going to be R. So I think it's B then.
Yeah.
Like this is R, and that makes R at the top, right? So saturated solution, that's a higher pH, yeah, that's true. Greater atomic radius, that's true. More reactive with cold water, that's also true for Q, right? So it's B. TK, is this clear? So we're moving on. Now, which element is the strongest oxidizing agent?
I think A because it's chlorine.
Which one?
A.
Yeah,
No, it's not chlorine. It's fluorine.
it is fluorine, right? So fluorine is one of the most electronegative elements and has the greatest tendency to gain electrons. A student mixes pairs of chemicals together in separate test tubes. So there's a mixes them. How many mixtures produce a white solid? Is the first one producing a white solid?
It produces calcium hydroxide, which is soluble, so no.
Partially soluble.
Partially.
So I think that will produce a white solid. I mean, lime water. It's always it's always has. I mean, it's like mercury. It gets. So we're not sure. We're going to check the answer for the first one. What about the second one? Is that going to produce a white solid?
Yeah.
How?
Barium hydroxide.
But that's
No,
soluble.
it wouldn't. It wouldn't produce because solubility increases.
I mean, they're all soluble. Any combination that's going to be soluble. Barium hydroxide, strontium chloride, they're all soluble. What about this one? Calcium carbonate with excess HCl.
It will produce calcium chloride, which is soluble.
Yeah, plus water plus carbon dioxide. So everything is soluble. So that's not going to produce it. And the last one.
Barium sulfate, which is insoluble.
So I'm going to go for two, right? The first one we're not sure about, but calcium hydroxide, I'm quite confident, like 90%, that's not entirely soluble, that's partially soluble. So when he says white solid product, that would be a possibility. So 15, it is C. So 15 is C. So just remember calcium hydroxide and calcium sulfate, they're both partially soluble. So they do form some precipitate. With which compound does concentrated sulfuric acid react both as a strong acid and as an oxidizing agent?
Is it C because of the bromide?
Yeah, that's you get redox in group 17 for this one. Ammonia can undergo an acid-base reaction with HCl to form ammonium chloride, which statement is correct. Like it's ammonia reacting with HCl.
Is it the last one?
Uh, yeah, this is tetrahedral, and methane is also tetrahedral. That's true. What are the trends in the stated properties in group 2 is descended from magnesium to barium?
Decomposition temperature increases, ionization energy decreases.
Yeah. Sulfur dioxide reacts with calcium hydroxide in aqueous solution. What is the product of that is first formed? Calcium hydroxide and sulfur dioxide.
Is it C?
Calcium sulfide, yeah. I don't know what he means by first form. That's the only thing that's going to be formed. Let's just check 19S. C. Yeah, that's fine. As a structure in stereoisomerism should be considered when answering the question. X, Y, and Z are shown. How many other isomers of this are there that are alcohols? And he says, so basically looking for all of them, right? So three carbons. You can't really have branch isomers, right? Yeah, how did he create a branch over here? No, that's not a. Is that a branch? No, that's not a branch. That's just three carbon atoms in a line. You're probably going to get this one wrong because we're going to miss. Probably going to miss one isomer. Just three carbon atoms, right? So
Yeah.
he went with two. He's already drawn two of them. He drew the Cl and OH on the first one. He said that they were forming stereoisomers as well. So that was two. Then the second one, he went with the Cl and OH on the middle one. There was only one because they didn't form stereoisomers. I said, now how can I put the Cl and OH? What are the other ways of putting the Cl and OH on these three carbon atoms?
OH could be on the first carbon and Cl on the second, or otherwise.
But that's going to be the same thing, right? Okay, so and it's not going to form optical isomers, right? Because there's no chirality, right?
Yeah, it could be first and second carbon as well.
Yeah, so first and second, or adjacent carbon atoms, right? Cl and OH, right? So
Yeah,
these are all your H atoms. Does this form optical isomers? I think the middle one does, right?
it has a chiral center.
Yeah, that's the only one. So that's two, right? So we've reached three. Is there any other way of putting the Cl and OH?
It could be OH first and then Cl on the adjacent carbons.
Yeah, that's another one. And it's still chiral, right? So that's two as well, right? So I guess
Yeah,
we've reached five, right? I mean that was the maximum. Okay, so we didn't miss any. 20 is D, right? That's fine. Two students each make a statement about 2-methylbutyronine. Student one states that 2-methylbutyronine has geometrical isomers. Does it? Butyronine and 2-methyl.
no, because it has two hydrogens on the terminal double bonded carbon.
So student one is wrong, right?
Yeah,
Student two states that this reacts with HBr in addition reaction to give 1-bromo-2-methylbutane. Is that correct? As the main product, so major product. So it reacts with HBr, right? Where will the H get attached? Right side or left side?
on the first carbon.
So the H gets attached over here and the Br gets attached on this one. And the double bond between them, that disappears, right? So what is the name of this molecule? 2-methylbutyronine. Is that the name? No. 1-bromo-2-methylbutane. Is that the name?
No, it's two bromo. So
Yeah, so that's both are wrong, right?
yeah,
The bromine would be on the second one, not on the first one. Which statement is correct when referring to the complete combustion of PVC?
is it the first one?
Yeah, this one is definitely wrong. It's going to be acidic. There's no need to treat the exhaust gases as a product of non-hazardous. They are. Yeah, that's the first one. Carbon dioxide. Iodoethane reacts with aqueous nitrate at 50 centigrade. Precipitate forms during this reaction. Which of the table is correct about this reaction?
It's nucleophilic substitution and yellow precipitate.
Yeah. Now this iodopropane is added to butyric acid by a two-stage chemical synthesis. In the first of the two stages, which reagents is reacted with iodopropane? So
Is it C?
this is but, right? So you need an extra CN, right? So it is C. Ethanolic casein. 1-chloro-1-methyl cyclohexane is hydrolyzed by heating with NaOH. The reaction pathway is shown. So this is a substitution reaction, and it's a two-step. I mean, this is a tertiary halogenoalkane, right? So what's the mechanism for a tertiary halogenoalkane?
SN1.
So what happens in SN1? What is the first step that happens?
Carbocations form.
So the Cl breaks away, right? And it's a carbocation. So the carbon will have a +1 charge. And then the OH will come in. An alcohol with the molecular formula C5H12O decolorizes well when you warm it with potassium manganate 7. So it's either a primary or secondary alcohol. It's also giving a yellow precipitate with alkaline aqueous iodine. So that means it's an alcohol which has a positive iodoform test. So it must have this thing. I mean, this structure must be part of it. So which one is it?
The first one.
I don't think so. Just a second. Isn't the first one tertiary alcohol? Butyl 2, all right. And 2-methyl, right? So that makes it a tertiary
No,
alcohol.
it's a tertiary, yeah. The second one is secondary and it gives a positive test.
Yeah, the second one, the methyl is on the second. Okay, so the methyl is on the third one, right? Yeah, so that's CH3 and CHOH. Plus, it's a secondary alcohol. As the next 127, which pair of test results would prove that a substance X is a ketone?
C.
It's a ketone. 2,4-DNP is that carbonyl and ketone no reaction, so that's fine. A product is found when this is heated when it's reduced, right? So what is the product? When it's reduced with NaBH4.
It's A.
Yeah, so only the ketone turns it back into an alcohol. What compound is chiral and reacts with Na2CO3 to give CO2? And basically it's an acid. Which one is an acid? It's supposed to be chiral as well.
B is excluded, it's not acid.
Yeah.
And C is an ester, so no. D has a chiral center.
So it's T. It's an acid plus this carbon is chiral. Here there is no chiral center. What is the molecular formula of compound X? I mean, you can do that. We can ignore that. Now, this question, nitrogen forms a number of oxides and enthalpies of formation are given, which statement is correct? If N2 is oxidized by O2 to NO2, this is the energy released per mole of N2O. So let's write the equation. N2O is oxidized by what? By O2 to form NO2, right? So if I need to balance this, it's going to be two NO2, right? So that's 4 oxygen. So I need 1.5 O2 over here. So that's 3 by 2, right? Can you tell me what the enthalpy change for this reaction is? It's going to be product minus reactants, right? Formation of products minus formation of reactants. Formation of O2 is 0. So 2 times 33 minus the reactants, which is 82.
It gives -16.
Minus 16, right? So that's fine. That's correct. Now the other one, he says the decomposition is exothermic.
Yeah, it's exo.
So it's basically the reverse of formation, right? It's turning back into its element. So N2 instead of forming, it's decomposing. So that's minus 82. So that is exothermic. The reaction between NO and oxygen is exothermic. How would you check the third statement?
I would write the equation for NO plus oxygen,
What is the product?
NO2.
Yeah, that's because that's the only product because
Yeah, half oxygen.
so that's 33 minus NO, that's 90, right? So that is exothermic. So all three are correct. Is that clear?
Yes.
So which statement is correct? Enthalpy of combustion of H2 equals enthalpy of formation of H2O.
Yeah, that's correct.
Enthalpy of formation of H2 is minus enthalpy of atomization of that's not correct, but this is no longer in your syllabus as well. So
You can't form an element for two.
this is 0, right?
Yeah,
Uh, because you don't have to do anything. If you want to form something from its elements, it's already an element, so you don't do anything. So this one is 0. Atomization is when you form it from its atoms. Or you break it into its atoms, right? That's what atomization is. So this will have some value when you have H2 and you break the bond and you turn it into its atoms. That is what atomization is. But that's not in your syllabus. So obviously these two are not the same thing. The last one, enthalpy of solution of HCl is equal to enthalpy of hydration. Hydration is also not in your course, so you can ignore that one as well. We can move to the next one. The units of Kc for an equilibrium reaction are this. What would be the equation for this reaction? So who's going to give you this unit? What's the unit for the first reaction? What's the expression for the first reaction?
um, it's we're not considering C because it's a solid,
Yeah,
so it would
so it's concentration times concentration, right?
yeah, it gives the unit.
So it's going to give you inverse concentration, right? What about the next one? That's going to do the same thing. It's concentration divided by concentration and concentration. So you're going to get concentration inverse, right? And what about the last one? That's also true, right?
All of them are right.
Yeah, concentration times concentration and then concentration times concentration squared, x is squared. So that will still give you x minus 1 at the end. So you're going to get this. Now 34, methanol can be... Which statement about this reaction is correct? He says this carries out at this. Yeah, which one is the correct statement?
First one is correct.
The first one. That's
Is it 1 and 2 only?
increase in temperature increase the rate of reaction because more effective collisions. Yeah, that's fine. Lower the temperature will reduce the rate of reaction because the forward reaction is. No, two is incorrect.
It's for the wrong reason.
If the reason is wrong,
Yeah.
it's got nothing to do with the forward or backward. It's just that the temperature is low, you got less kinetic energy, you're going to get less effective collision, and you're going to get less frequent collisions as well. Increasing the pressure reduces the rate, it increases the rate of reaction of that. So only one only, I think. Which one correctly shows the relative electrical conductivities of the sets of three pH3 elements?
It's 1 and 2 only. 3 is wrong.
So three is wrong. Yeah, that's fine. Three tubes X, Y, and Z contain water, which a short a universal indicator is added. So what are the pH values for these tubes? NaCl, what's the pH for that?
7.
And SiCl4 and AlCl3, they're both acidic, right?
Yeah. So
So
all of the statements are right.
all three are correct. It has an MR of 116. I mean, you have to count it. It contains two groups that show strong absorptions between. So this is the carbonyl group, right? Strong absorption. So does it? It has, right? It's got two groups. So this is fine, right? Number two. Is that clear?
Yes.
What is the strong absorption in the 2500 to 3000 range? I mean, you don't have to.
OH.
Huh?
OH, I think.
Yeah, that's an OH and that's a carboxylic acid OH, TK. I mean, the chart will
Yeah.
be right.
But it's saying it's only infrared absorption.
Yeah, this is not actually sharp and strong. Like if you look at the data booklet, where's the data booklet? Yeah, the carboxylic acid absorption between 2500 and 3000, that's strong and that's very broad. Is that clear?
Yeah.
So it's going to have that, but it's just not going to be sharp and strong. So um, I mean, let's just take this 137, right? That is B. The last one is wrong. Now, during the bromination of methane, the free radical, this thing is generated. A possible termination of the reaction is the formation of C2H6, where two methyl radicals they combine. What could be produced in a termination step during the bromination of propane? So in methane, you get methyl radicals. In propane, you're going to get which radicals?
Profile.
Right? So, and how many types of propyl radicals are possible? Like, you got propane, right? The UV light comes in, the halogens come in, and they steal away one of the H atoms. So you might get one H missing, right? So the carbon will become a radical. Now tell me, how many different types of propyl radicals are possible?
Is it 2?
Yeah, two. It's either going to be at the end, the H missing at the end, or it could be an H that is missing in the middle, right? So those are the two possibilities. Now tell me what combinations could be produced? Like, I mean, two propyl radicals could attach themselves end to end, right? So this propyl radical, and there's another propyl radical, right? And they could join up right in the middle, right? So that's one. I don't think that's given in the answers, right? Now tell me, is the first one possible? The first one, then
Yeah.
so is this possible when two propyl radicals add up? And it's not possible. How can they form this? Like if you split them back, you can't split it into two sets of three. Like if I split it over here, I'm going to get a four carbon atom and a two carbon atom. How can I like split that one into two groups? I mean, like this thing, two propyl radicals joining up. Is that clear? I mean, I can't do that for the first one.
Yes.
For the second one, can I do that? It's two carbons, then there's a methyl branch, then there's another carbon atom, and then that one has two methyl branches, right? Can I split this one into two propyl radicals? If I split it in the middle, then it's this radical. I mean, it is two propyl radicals, right?
It's possible.
And then the last one would also be possible. That's methyl, and then you have another C, and then C and C, right? So I can split it into two propyl radicals. This one would be the radical, and this one would be the radical, and they're joining up. So it's basically this one joining up with this one. That's what's going to happen. So this one is also possible, right? So the last few questions, you got the reaction of primary alcohols are listed. Which one would give water as the product?
First one, yes. Second one as well. All of them.
Yeah, that's acid. Yeah, that's ester. Yeah, that's water. Yeah, all of them produce water. Which reagents react with? I mean, it's an ester, right? It's a polymer, but it's an ester. So which one would react?
Sulfuric acid. 2 and 3 won't react.
I think these two will react. Esters, they do get hydrolyzed, right? With you got acid hydrolysis and you got alkaline hydrolysis. Sodium only reacts with either alcohols or carboxylic acids. Is that clear?
Yeah.
Must be good. So we're done with this. So we're going to continue tomorrow then as well. Do you have a practical exam on 30th?
Yeah, I do.
We can practice practical. Which variant are you giving? I mean, is it 3-4?
No, I'm variant 2.
Hmm?
Variant 2.
So you're giving variant 2. Okay, so do you have any idea what's coming in your practical?
Not really.
So we can practice questions related to moles and stuff. Okay.
Okay.
Okay then. Take care. Yes.